We usually think of large organizations, networks, and institutions as these massive, well-oiled machines, inherently aligned and all pulling in the same direction, right? But what if that alignment is just an illusion? In this explainer, we're going to take a clinical, detached look at a pretty chilling reality. We're going to see what happens when the very structures we build to succeed are mathematically programmed to tear themselves apart. You see, whenever a system gets large, it immediately hits a crippling wall, the slow, suffocating bottleneck of central planning. The authority at the top just can't process information fast enough to direct every single action on the ground. The universally accepted fix for this is decentralization. By pushing decisions down the hierarchy to local stations, we free up the system to react, adapt, and move a whole lot faster. It just makes sense. But almost immediately, we hit an inescapable consequence. As local autonomy goes up, global alignment shatters. When you give independent parts the freedom to move, they inevitably start moving in entirely different directions. The overarching structure begins to pull itself apart. And this isn't by accident, and it's not because of bad actors. It's happening purely by structural design. To really picture this, imagine a huge, branching fluid pressure manifold. All along this vast network of pipes are autonomous local relief valves. When pressure builds dangerously in one specific spot, a local valve opens up to relieve it. But if every independent valve acts completely on its own, opening based strictly on its own local readings, the global pressure of the entire system zeroes out. It drops to 0.0 psi. All forward flow completely stops. Which brings us to Section 1, the local optimization trap. The whole process starts out so logically. Decentralization delegates authority downward. Whether we're looking at a global supply chain, a massive tech platform, or a healthcare network, organizations push decisions down. The people closest to the problem, like warehouse managers or local content moderators, hold vital, on-the-ground facts that a distant central planner simply cannot see. So local actors naturally optimize their local environments. You get these highly distinct units making incredibly rational, independent decisions just to maximize their immediate localized objectives. A regional distribution hub maximizes its specific regional output. A local engineer patches a highly specific software error. In their own little spheres, they are functioning perfectly. But here is the severe structural trade-off. In exchange for all that local agility, the central authority mathematically loses control. They fundamentally lose the ability to observe, monitor, or dictate the exact behaviors happening on the outer edges of their own organization. The overarching system has traded visibility for speed and is now, effectively, flying blind. And that blindness leads us into Section 2, the metric distortion. Because the central authority has lost visibility, it desperately attempts to artificially enforce alignment using numbers. Piece rates, quotas, performance-related pay. And instantly, a strict new rule of survival takes over. Rewarded metrics optimize. When an agent's survival and compensation are tied to a specific measurable target, those local actors are going to redirect absolutely all of their energy into hitting that exact number. But this intense optimization has a dark, inevitable consequence. Unmeasured variables degrade. Complex, vital tasks that don't fit neatly on a scorecard, things like long-term maintenance, building organizational trust, or just helping out a struggling peer, they get completely abandoned. If a task is unmeasured and uncompensated, it mathematically ceases to exist for the local actor. If we return to our physical manifold system, the autonomous valves are now stuck wide open. They are continuously venting to relieve local pressure, completely exhausting the system's core energy. Every single valve is functioning perfectly as designed, and because of that perfect execution, the machine is bleeding out. The system fractures. This fracture deepens into Section 3, the coordination collapse. Let's look at the cold mathematical reality of survival in this fractured environment. Imagine a scenario where securing a massive outcome requires everyone to work together. To choose the action of cooperation, you require mutual trust, and the risk of someone letting you down is incredibly high. But to choose defection, to just abandon your peers and focus only on your individual output, requires absolutely nothing. The risk is zero. Cooperation requires trust. Defection requires nothing. Because the system is heavily rewarding isolated, individual metrics, the cost of peer coordination becomes far too high to justify. This triggers a cascading, highly rational retreat into safe self-preservation. Everyone stops helping everyone else, simply because helping doesn't pay. Now that the system is fully locked in failure, we enter Section 4, the principal-agent divide. We have officially reached a state governed by the principal-agent problem. This is the formal structural conflict that occurs when a delegated actor's interests inevitably diverge from the delegator's goals. And notice, there are no villains here. This isn't a behavioral flaw or some moral failing. It is an unavoidable mathematical divergence between the entity requesting the work and the entity actually performing it. This conflict is driven by a profound imbalance. The agent on the ground holds hidden information about their local environment that the center simply cannot see. Because of this blind spot, the agent's divergence from the original goal isn't just a mistake. It becomes a permanent, hard-coded tax on the organization. The system is structurally forced to pay for its own lack of visibility. Which brings us to the final escalation. Section 5, the inevitable structure. When the system finally realizes it's failing, the attempts to fix it actually finalizes its destruction. One attempted fix is intense surveillance. The principle applies heavy monitoring to reduce variance and force compliance. But this cure is totally toxic. High-intensity monitoring completely destroys the local agility and flexibility that the decentralized structure was built to harness in the first place. The principle regains control, but paralyzes the entire organization. Alternatively, the system might try extreme competitive incentives, like winner-take-all tournaments. But these structures incentivize catastrophic risk. The compensation scheme turns into a highly volatile gamble. It pushes agents to take unmanageable, systematic risks to win outsized asymmetrical rewards. The individual agents capture the upside of the risk, but they offload the catastrophic danger onto the entire organization. Looking at our physical manifold one last time, it completely locks open. The core pressure is entirely drained. The autonomous valves are irreversibly jammed in their open positions, and all forward flow has permanently ceased. The system is dead, destroyed by the very mechanisms built to sustain it. We are left staring at a chilling core contradiction. Rational local behavior creates global failure. Every single part of the organization functioned perfectly. Every actor followed their local incentives to the letter. No one acted irrationally, and yet the collective entity was utterly destroyed by that exact rational precision. This leaves us with a final, profound realization. The system did not fail. It followed its structure. The loss of alignment wasn't an accident, a mistake, or a symptom of poor leadership. It was a structurally determined inevitability. When we build complex environments and push decisions down, are we truly designing for cooperation? Or are we simply winding up a machine and waiting for the cold math of failure to finally play out?